How the brain creates your taste in art. How the brain creates your taste in art. You're listening to Technical News Reading presented by Hakeem Alibokis Alexander on Spreaker Social Podcasting, presented for World Reading Club in association with Uniquilibrium. This edition's reading focus comes to us from neurosciencenews.com. It was published on February 27th, 2023, under the categories of neuroscience and open neuroscience articles, and is titled How the Brain Creates Your Taste in Art. What the hell? And summary. Using a combination of machine learning and neuroimaging data, researchers revealed a neural basis for the aesthetic appreciation. Source: Caltech. It has been said that there is no accounting for taste. But what if taste can actually be accounted for? And what if the things doing the accounting are the neural networks inside your brain? In a new paper published in Nature Communications, a team of Caltech researchers show how they have revealed the neural basis for aesthetic preferences in humans using a combination of machine learning and brain scanning equipment. The work took place in the lab of John O'Doherty, Caltech's Fletcher Jones Professor of Decision Neuroscience, and builds on research published by that lab in 2021. In that previous search, scientists trained a computer to predict volunteers' taste in art by feeding it data about which paintings the volunteers liked and which they disliked. With enough training, the computer became adept at correctly guessing if a person would like Monet or Rothko, for example. The act of liking or disliking a piece of art seems so innate and occurs so instantly and seamlessly in our brains that few of us have probably taken the time to wonder why or how it happens. But aesthetic preferences have been the subject of philosophical discussion for years. When you see a picture, you decide immediately if you like it or not. But if you think about it, this is really complicated because the input is very complex, says lead author Kiyohito Ligaya, formerly of Caltech and now with Columbia University. This is actually a very open question, and we haven't really known how the brain manages to do it. So, we were wondering if we could understand it using a computational model. That method involved having volunteers rate paintings as many as 1,000, and over the course of 4 days, while their brains were scanned with a functional magnetic resonance imaging machine. That method involved having volunteers rate paintings, as many as 1,000, over the course of 4 days, while their brains were scanned with a functional magnetic resonance imaging machine. Those brain scans and the volunteers' ratings of the paintings were fed into a machine learning algorithm, along with the output of a neural net trained to examine the paintings for contrast, or to examine the paintings for qualities like contrast, hue, dynamics, and concreteness, whether the painting is abstract or realistic. The data the team collected showed that areas within the visual cortex of the brain, or of the part of the brain that processes visual input, are responsible for analyzing these qualities. And, basically, hold on, what the heck? Okay, here we go. The data the team collected showed that areas within the visual cortex, the part of the brain that processes visual input, are responsible for analyzing those qualities. An area in the front of the brain known as the medial prefrontal cortex is responsible for assigning subjective value to them. Basically, the brain breaks a piece of art down into its essential qualities and then decides whether those qualities are pleasing or not. This is more or less the same way the brain decides if it likes food or not. Conducted by the Doherty lab, that study found that the brain analyzes a food according to its protein, fat, carbohydrates, and vitamin content, and then determines if those qualities are pleasing. What they found is that the brain integrates those different nutritional features to produce the overall liking of food, Ligaya says. That's actually an inspiration for our work. In their paper, the researchers say their findings suggest that this value construction system may be widespread throughout the brain and may explain many kinds of preferences. I think it's amazing that this simple computational model can explain large variations in preference for us, the guy says. One more time. I think it's amazing that this very simple computational model can explain large variations in preferences for us, the guy says. About this art and neuroscience research news. Author, Press Office. Source, Caltech. The original research is under open access and is titled Neural Mechanisms Underlying the Hierarchical Construction of Perceived Aesthetic Value by Kiyohito Ligaya and others in Nature Communications. I should go to sleep, but I'll be right back in just a moment. You've been listening to Technical News Reading, presented by Hakeem Alibokis Alexander on Spreaker, social podcasting, presented for World Reading Club in association with Uniquilibrium. Neuroscience News continues with an abstract from the paper titled neural mechanisms underlying the hierarchical construction of perceived aesthetic value. Little is known about how the brain computates the perceived aesthetic value of complex stimuli such as visual art. Here, we used computational methods in combination with functional neuroimaging to provide evidence that the aesthetic value of a visual stimulus is computed in a hierarchical manner via a weighted integration over both low and high level stimulus. Features contained in early and late visual cortex. Studying, I know. Yeah, oh my gosh. Here we used computational methods. Wait a minute, what is? Oh yeah. Here we used computational methods in combination with functional neuroimaging to provide evidence that the aesthetic value of a visual stimulus is computed in a hierarchical manner via a weighted integration over both low and high level stimulus features contained in early and late visual cortex, extending into parietal and lateral prefrontal cortexes. Feature presentations in parietal and lateral prefrontal cortex may in turn be utilized to produce an overall aesthetic value in the medial prefrontal cortex. Such brain-wide computations are not only consistent with a feather-based mechanism, such brain-wide computations are not only consistent with a feature based on mechanisms for face value content, but that also remembers too. Anyway, our findings shed light. Our findings thus shed light on the existence of a general neurocomputational mechanism for rapidly and flexibly producing value judgments across an array of complex novel stimuli and situations. You've been listening to Technical News Reading, presented by Hakeem Alibokis Alexander on Spreaker, social podcasting, presented for World Reading Club in association with Uniquilibrium. You can read this article and others like it for yourself by visiting neurosciencenews.com. That's neuroscience.com. That's it. How the brain creates your taste in art. Half fallen asleep there, but I think I got it. How the brain creates your taste in art. Yeah. So I really want to stop broadcasting, yes.